Hello, my name is Neil, and today we are in episode 1, which succeeds episode 0 about seed finding and how to actually do something useful with the library. So in first, well, not first episode, but in episode 0, we actually saw how to set up the environment. And now that you actually have an environment which is set up, we can actually do some stuff. So today we are looking at making 4 programs, which will be from the simplest to actually a very complex one. So I'm revisiting an old program I made a while ago, but yeah. So it's a widget finder, so it's quite useful for people. So the first thing we will make is find a widget seed with a set position. So we say that we want, for example, a widget at this position, and then we find all the seeds that satisfy this requirement. Then we want to find some widget coordinate on a set seed. So we have a seed because it's our word seed or it's a seed we found and we want to search for it. And then we want to collect all the widget on that seed because we want to run some analysis. Then sometimes you want actually to find some stuff, some useful stuff like a quad widget because it could be useful for farming redstone or stuff like that. And the third program will be find a quad widget seed. So any quad widget seed at any region, and we will talk about this later, could be found with this program. And then we will find the quad widget on your set seed. Of course, this will not be likely, but I will show you how to actually do it fastly. So that's the for program, but of course I'm making an emphasis on widget, but actually all the program could be translated to any structure. And that's actually crucial. And in all the program I will actually make sure to show you how you can actually change it to apply it to any structure. So that's for episode 1. Just a sneak peek, in episode 2 we will be looking at loot, and that will be actually a bit different, and we will see for episode 3 way later. Anyway, this episode will be quite long. This intro already is being quite long, and I will try to put some time code in the description for each of the program and for some of the steps. So, without further ado, let's start with the first program. So as you can see, I made just a main method. If you execute it, you will get a prompt telling you, choose a program, and then you can actually enter and run the program. It's just a utility because I'm a bit lazy, but actually you can run them all because they are all implemented runnable. So let's go to our first program, so this one. As you can see, it's run, and the objective is simple. Find a seed with a few specific swamp up. So the first thing you need to know about generation, and now I need to actually use paint, is it happens in a grid pattern. So you have your world, and actually you have a grid which is called the region grid, and on this region grid only one structure, only one of a type of structure can spawn in a square, in a cell. So for example, a swampert can only generate air. If a swampert generates air, then it cannot generate in this square again. It can only generate in other square. And this happen in a weird way if you never saw it before. So this is my map. It's just a mist, but with a few more utilities. So I will create a random seed, and I will show you something interesting. So if you look here, you will find let me actually disable the biome so you can see only the structure, and I will show you the region grid. So if you look a bit closely, you will find that most of the structure will spawn only once in a region. Of course, there is some exception, and we'll talk about them later, but the same rule is for a region which is actually tied to a structure, but there will be only one type of structure. And if you actually enable, for example, the structure seed mode, you can actually see that very clearly. So for example, one village here, one village here, one village here, one village, and swamp and so on. So you see only one per region. So the catch actually is not all structures have the same region size. So for example, you see that the bird treasure, they spawn way more in one region, and that's because they have a region of one chunk. So a region is usually 32 chunk for most of the structure, but actually for some it's not. So for example, for Ocean Monument it's not, for Mansion it's not, for Buried Treasure, well, it's one chunk, so they can actually spawn at any chunk. So they can spawn only once per chunk, but they can spawn in any chunk, as long as they actually fulfill some requirement. And to actually get the position of the structure in that region, you need to call the RNG, which is set with the world seed, but actually one part of the world seed, which is the 48 lower bit. So if you are not familiar, world seed is 64-bit, and because Java use Java random, which is LCG, you should check out Matthew Bolan video if you are not familiar with that. I will not go in detail, but basically it only shortens the seed to 48-bit, and thus when you actually do the RNG call, you only get something which is applied to the 48-bit lower bits. So yeah, they do a roll and they select a position in that region, and that's actually where it will spawn. And after that, there actually is a filter which filter for biome requirements. So for example, village can spawn in most biome except ocean, for example, or some stuff like tiger. Well, yeah, there is some requirement, but swamp up can only generate in swamp hill and swamp biome. So yeah, they are quite restricted. So that's exactly what we will simulate, and I just wanted to give you some background in case you completely forgot about that or you are just new. Remember, there is way more resource. I will try to list some in the description, but for now that's all you actually need to get into it. So we are done with that. Now we can actually start. So as I said, there is only one swamp up per region. So you might want actually to not search for position, because that make no sense. Because if you, for example, I shouldn't have closed it. Darn it! I forgot. Yeah, that's me not prepared. I should have not closed it. So if you look in the region, you cannot just find it right next to each other. So that doesn't make sense to search it for position. That doesn't make sense to search it through chunk position. We only care about region position, if that makes sense for you. So first thing you want to know about the API is what we call the position. So there is three types in our API. There is a B position for block position. So this usually you call it B pose, and then you create a block pose. That's really easy. So you give it the X, the Y, and the Z, and then you have a block position. But you can have also a C position, so a chunk position, and this is done by converting so the B position to a chunk position. And what does that do? Well, it basically just multiply by 16. So shift by 4 is multiplied by 16. If you're not familiar with that, I recommend to actually learn a bit about that. But for example, yeah, so divide by 16, my bad. Multiply will be shift right. Yeah. So to chunk position, it divide by 16, and if you get a chunk position and then you convert it to block pose, it multiply by 16. So for example, 16, then to chunk position we should get a B position of 1, 0, 1. Then you can actually convert it to region position, so air pose, and that's done also. Well, you can declare it if you want, so that gets like a X, a Z, because there is no Y in region, because it's not actually dependent of the Y position. Block position depend because it's in the world, but the chunk position, region position is only on the on the 2D plane. And then you actually need to provide the region size, and the region size, like I said, is actually dependent of the structure. So for example, if I get my swamp up and I create one, then I can actually get the spacing. And the spacing, if you actually look a bit into it, you will find, yep, and then here you will find the spacing is 32 chunk. Separation is how much it cannot spawn in. So in a square, it can only spawn in the 24 first chunk of the 32, and the 8 last it cannot spawn. So that means that actually, because the squares are next to each other, there will be always 8 chunk of difference between two swamp up or two structure, because one can only generate at max at the 23rd chunk, and the next one could be in the 0th chunk. So yeah, let me just. So yeah, also we need to provide a version, and that will be for just being well, a bit useful for everything. So we'll just generate a version. So let me copy it. So there is a MC version which have every version from alpha to the current one, so 1.17, and those are actually kind of verified for most of the stuff we provide in the library and are working. So for example, for biome, everything in here is working except the alpha part, so I think it stopped at beta 1.8 or maybe yeah, anyway, it should throw you an exception if it's not supported, and of course we will try to expand it. So I select a version. I will say that we will use latest version. I suggest that you actually fix it to something, because it's yeah, it will allow to not have like something break in the future version. Then you want to create your structure. So here we will use a swamp up, so I will just name it swamp up, and then the version. I forgot to put the type here. Okay, so here I have my structure, and because I want this to be useful to anyone, I will actually use the current structure, which holds actually a reference to this one. So if I, for example, I want to use a desert temple or desert pyramid, I can actually create a desert pyramid and then just so a desert pyramid here, and then switch this one here out, and yeah, it's a bit easier then. Okay. So now that we have this stuff, we can actually fix this one. So for example, we use current structure, get spacing, and so here you will actually create a region with actually 32 as block position and not as a strength position, so you actually need to multiply it by 16. That will not be the case if you, for example, create it from a CPOS or CPOS to region POS. Then you actually just say the chunk spacing. Yeah, so you have to be conscious of what context you are calling it from. So if you are converting, for example, a PPOS to a region POS, then you actually need to get the spacing, so in chunk, and then multiply it by the size of the chunk. Of course, you can also use a bit shift if you fancy that. So that's for position. That's really important to know that, because we will use them extensively, and I don't want you to be lost in what I will be doing. So first thing we want to do is actually declare a chunk run. That's for optimization purpose. Usually you can use it in code directly, but we prefer to have one at the top. Of course, because it's not thread safe when you are using it in some stuff which are threaded, then you actually need to use it locally in each thread. Anyway, so we want to find a word seed which satisfy a requirement. So the requirement, we can say that it could be that we have some region which contain a swamp up. So my two regions I chose are 0, 0 and 0, 1. So if I get back my paint, I actually want a swamp up in this and this. This being 0, 0 and this being 0, 1. That's just my condition, could be anything really, but that's just for example. We'll see how to actually change everything later. So the first thing you want to do, as I said, it's the word seed is 64 and it's split in 16 and 48. So because only 48 actually choose a position in that region, we can actually first look only for the 48. So we will just iterate for the 48, so I will call it structure seed because that's actually the correct name, and then we will iterate through the 48 bit. Of course that's a long. So 1 shifted by 48 is actually 2 to the power 48. That's bit shift, I mean it's useful. Then we will create a new CPOS position. I think what I'm doing is a bit bad because I'm making a tutorial by looking at some code I actually pre-made, which might look odd to you, but I try to actually show you what I want to do while I typing it. Maybe not by a good idea. Maybe for the next episode I will change that, but anyway. So now I'm iterating through all the my position I want, my swamp bit, and I want to actually get the chunk position in that region. So if you recall, it selects a chunk position in only the chunk which are possible in the region. So for that there is actually an utility you can call. So in current structure you can call get in region, and this, if you look a bit into it, it accepts a structure seed. So as I said, only the 48 lower bit, but you can actually get put the world seed, but it will only care about the 48 lower bit. That's why we only choose 48 lower bit. Then in it region X, which is the region we want actually to have the structure in, region Z, and then a chunk run, which is used for optimization. Usually we put it outside of everything because it's a bit bulky. So we get our position here, and then we get our rend, and we have now so structure seed, I forgot that one. We have a position, a chunk position now, which is available to us. So because we have now a C position, we can actually check if actually at that position it's able to actually generate that structure. But because we are actually in a for loop, because we want to check that both of our region actually generate them, we will add them to a list, we'll store, and so on. Of course, what I'm doing is how we will do it if I'm doing everything imperatively. Of course, I will show you how to do it with a stream and how to actually do it way faster, but that's not right now. We are just doing it the normal way if you are writing like C code or something like that. So you want to check first that the CPOS is not null, because some of the structure will actually return null for the position because they are actually dependent of a second RNG call. For example, I can cite Bastion, Fortress, Bird Treasure. So you want to actually have this check because this could be null, and as always, all objects could be null, so always check that. And if it's not null, then we can add it to our list, and we have the list with all the 2 position at most. That's why I initialize our list with a capacity of 2 at the beginning, because I know that I can have most 2. And now I want to actually do a check to see that actually I didn't get any null, because if I got a null, then I actually know that there will be no structure in that chunk. Of course, for Swamp Up it's not the case because they will generate in all regions, but for example Bird Treasure it's not the case. So now that we actually are fixed, we have a structure seed here, which we know that have 2 chunk position, which are valid for Swamp Up. So now we want to iterate through the upper 16-bit, and for that we will just create a new loop, and then we will iterate through the 16-bit. So I will put a long here because it's a bit easier for us. I'll rename that. and then we will create the word seed. So as I said, the word seed is actually the upper bit, so upper bit at the 40th position, then the structure seed. If you are not sure about this formula, you can actually use an utility in structure seed. So in structure seed there is actually two word seed, and it accepts a structure seed and upper bit. And this will actually do exactly what I put before, which is shifting by 48 and then concatenating the structure seed at the bottom. That's all it does. Let me rename that to correctly then. And now we actually want to check the biome. So if you look previously, we had like here a swamp up, but actually the biome is plain, and thus if we disable it, then we see that we don't have a swamp up. But here it's a swamp under the HUD, so we get actually a swamp up. So we want to actually create a biome source. So if you follow episode 0, you actually know how to do it, but if you don't, then you just create it through biome source and off, and then you can select the dimension. So of course here we are in the world, and then you need to select the version. Of course it's a static thing we declare upward, and the word seed which we just created. Now we have a specific biome source, and because a biome source only uses a full 64-bit, then it cannot be split into the structure seed or move up and so on. It needs to be done here as a check. So that's why you should always do all the requirements you can do on structure seed first, then actually do the biome. Here we are doing it because we know that we want only that requirement, but if you actually want to do something more complicated, you want first to iterate through all the structure seed, then at some point, for example, not all structure seed, for example, you could iterate through 32 or something like that, and then say, yeah, at this point I want to check biome and print some result. Because each time you are doing this check, it's actually way slower, because biome source is quite slow, and that's because it's generating all the biome. So now I want to check that both of them actually spawn. So I will just create a boolean. So I will initialize it at true because, well, I like to have stuff at true. And then I can iterate through all the position in my cPost list. So remember, those are chunk position, and which are needed because there is actually another utility. So I will just XOR the result, end the result actually, with the result of our utility. So swamp up and can spawn. Can spawn actually tell you if it can spawn at some place. So it accepted data, usually you don't want to use that, or it accepts actually a cPost, so you can just put the cPost in it, so chunk position, and then you need to provide a source here and so on. You can also provide the chunk X and chunk Z, and yeah, and you get it. And so if can spawn at both, then we can actually print it, and we actually have a word seed which will generate a swamp up at this region and this region. So if we now execute that, because I will not try to use the main, I will just create a main here locally. If we execute that, so we'll learn a bit first, because of course it needs to do also biome check and so on. So let's create that utility. Might take a bit of time, sadly. I mean, we started at 0 and not the first one is directly a correct one. Yeah, making the elevator music in the meantime. Come on, you can do it. Okay, so now it should start printing some stuff. So that's the first seed, which is actually valid with biome to actually generate two swamp up. So if you look closely, I will show you actually the grid. You will see that in 0, 0 there is one swamp up, and in 0, 1 there is one over. So that's great, but actually we only say that we want one in that region and one in other region. But for example, we might want actually to have them really close to each other, and that part we can actually do it here. So we, for example, can get a distance metric, and so Euclidean, for example, or Chebyshev, let's take Euclidean, and get the distance between the two. So suppose let's get 0, get x, and so on. So yeah, we need to do all of those for all the. So yeah, so let's get y, get c, and so if the distance is, for example, inferior to, well, I said that the minimum is 8 times 16, for example 10 times 16, then we continue. So we don't break. But if it's not, then we can actually, so let me actually, if it's not, then we should continue. We should not go in that part, we should actually loop back. And so if we actually start, so let me start at this one, because to structure seed, let me start at this one because it doesn't need to be started before, because that's the first seed which is valid. And as you can see, we can see that actually those were 10 chunk apart. My bad, actually. So CPOS, yeah, should be inferior to. That's actually in chunk. That's not in block position. That's my bad. That's why it's actually easy. So let inferior to 10. Now it should be a bit harder for him. Let's take 13, I guess. Okay, so now we get actually a bunch of seed. So if I load this one, yeah, so as you can see, they are way closer together. They are actually 13 chunk apart at maximum. I think it's a bit less. If you actually get the roller, it's 116, so that's 11 chunk. So as you can see, everything you can do on structural seed level, you should do it before the biome, because it will increase speed tremendously, of course. Okay, so that's our first example. It's not the prettiest one, but yeah, that's our first example. So now we can start on example 2. So this one is different, is find a Witchshot position on a set seed. So that's actually way easier because of what we saw. So we will first just copy some basic stuff we had before, so all of those, because I don't want to copy them each time. Yeah. So we have a word seed, which is our input. So for example, I will search on seed 1, and then we want to search on that seed all the position of the swamp up. So for that we want to iterate both on X and Y axis. So there is a fancy way. I will actually show you a fancy way to do it, but for now I want just to do it in a simple way. So we will iterate on region X. So we will iterate from so we will name that bound, because oh, darn it, I don't want to have that. So I will just create a variable called bound, so that will be our size of region. So that's an int. So for example, I think 200 region out is enough, and then we will go from negative that one until the positive, and then we will do the same for the seed position. So bound and minus bound. Okay, so now that we actually have a word seed, we can actually optimize stuff, because we know that it's constant. So we can actually create the biome source up there directly. So that will be our biome source. The dimension we will still stay in overworld because our swamp up is in overworld. Of course, you can change it if you are in different dimension. By the way, you can actually use that. You can use swamp up, get valid dimension, and you can actually make it completely dependent. Oh, and if I go back to my example, I think I messed up some part because I actually use swamp up instead of that. Yeah, I will clean everything up and put some comment, of course. And then you need to provide the version, and you can provide then the word seed. And because it's constant, the source is constant, so it will not change. So now that we have a source, then we can just check that actually the swamp up can generate, so can spawn my bad. So get in region first. So in region we can provide the structure seed, but the word seed is fine also. The regex, red z, and the chunk run. So let me define the chunk run here. Okay, and that will give us a CPOS like before. There's nothing hard about that. We always check that the CPOS is different than null, so if it's equal to null, then we can just continue. Did I actually make it? Oh yeah, it's correct. So if you are null, then you just continue this loop because you don't want to go back here. And then you want to check that if swamp up can spawn, then we want to print the position. So let's actually use a printf. So TP add player. Then we want to impute a number, then the tilde, and another number. And then we want to use cpos to blockpos get x, and cpos to blockpos get z. Okay, so, and of course we want to add a new line. It's always hard to forget, easy to forget that part. And now we can actually find on all that structure seed all the position of a swamp. So if I create a main method and I call my quad widget pathfinder dot new, then actually, oh my bad, actually I'm the wrong file. That's actually pretty bad. Let me actually switch everything here, so that part I can actually remove it. Let's re-implement the runnable. I want it to actually be in that folder. I'm sorry. So yeah, and then we actually get all the position, and that's actually if you look in my map and load that seed, so 1 in version 1.16, 1.17. So if I go, for example, at 2336 minus 968, I will find a swamp up. And of course, it's the same stuff which are happening when you're actually listing the structure here. This is basically what I'm doing. So that's how you do it, but of course you can stream that and parallelize everything, because yeah, of course. So biome source is technically not thread safe, but as well, the cache is not thread safe, but as it will only fill up until some point, it's fine enough. And if well, the cache have an issue, then it will just resample the area, so it can be used in threading to some extent. It's better to actually have like a local source for each one, but so for example, here I could create in stream, so range, and then I create minus bound to bound, and for each I can then just value, well, actually regex, and then I can just put that part here, and now I can, yeah, remove that part. And if I want, actually, I can put parallel here, and then that run in parallel, so it's actually way faster. Of course, as I said, chunk run is not, so we're not thread safe, so you might want to actually create it here. And same for the source, you want to create it from actually each thread. So you want maybe to have a fork join pool and so on. But for basic threading, it will work and will not throw much issue, but it might have some concurrency issue. So yeah. And of course, if you actually want to do something a bit nicer, you can actually use an utility I put here, which is called structure helper, which uses a spiral iterator. So this basically, if I copy that part and put it in here, so here, so spiral iterator, and then so my bad. Oh, it's not the black. That's my bad. Yeah, I always forgot to put some stuff black, but yeah, it's an utility I made separately. It's in my map, to be honest. So if I add stream support to that part here, let's put it parallel, and then so that part. I'm doing some stream stuff. It's not fun. Well, it's a bit annoying to do. Split iterator ordered, and then for each, then I can just print them. And then, yeah, if I call that, I will get a spiral iterator. So yeah, if I go at the top, it starts from 0, 0, and then grow outward, so it will go in that way. It's a bit better when you want to search from a certain point and then go outward. And that actually there is an utility here which actually do exactly what I did, but with stream. So it gets the closest for any structure. You need to provide the current position, so center point, a word seed, a source, so you want to provide a biome source, a terrain generator, so that's for some of the special structure. I will go back to that later, and the dimension coef, so that's because sometimes you want to have structure in overworld or structure in the nether, but they actually don't spawn in that, so that's to dealing with that. Usually you want to put one here. And as you can see, it actually does exactly what we did in that class. So it gets the region size of that structure, then it gets the center position of that block position. So of course it multiplies chunk spacing by 16 and so on. It creates an iterator based on that center air post and that region size, and then so it creates a stream of that. It gets in region the structure. So if you look here, it's just a thin wrapper to actually call the structure and so on. Then it filters the non-null. So if there is a null, for example, for buried treasure, for bastion or stuff like that, then it actually doesn't matter. Then it filters if it can actually spawn. So if it can spawn, then it's a valid biome. and it's a valid position, so yeah, it's okay. And then for some structure like NCT and so on, you actually need to generate the terrain to actually be sure that it can generate at this place. So you want to call it current generate, and then with a terrain generator. So a terrain generator is something as a biome source. You create it with auth, dimension, and a biome source, and it will create itself for any version. Sadly, it's only supported for version upward of 1.13. So yeah, for now, that's why there is a check. If it's null, then yeah, usually you want to provide a null. If you are not sure, it will just not do that filter. And then it actually maps a chunk position to a block position and do the shifting for the different coef of dimension and so on. And if it's for a stronghold, there is actually a different method which is called get all start, which actually gives you all the C position for the stronghold, because there is 128 for 1.8 plus, 1.9 plus, and 3 for below. 1.7 plus, my bad. Yeah, at 1.7 it between 1.7 and 1.8 it changed 3 to 128. Anyway, so yeah, if you want, I will provide this utility. It's a bit nicer because it does the spiral iterator, so it goes from inwards to outwards, and it's a bit easier and a bit better than just doing like a square scan line. So yeah, I'm doing actually a scan line, and yeah, it's a bit boring to do like so. Anyway, I will go back to the old version here, because I don't want to actually left you with the stream stuff, because I don't think it's actually beneficial for you to say that. But yeah, that's how you actually get all the structure position for a specific structure. So here again, swamp up, and here again, yeah, for a current structure in a specific one seed. So now I actually want to go back to our first example and just show you actually how you can improve a bit the formatting. So for example, you could use a long stream here, so for a range, and then just go here from 48. Then you could for each, so you could just filter. Well, you could first map, and then yeah, so this is how you actually map it. So, so structure seed, and then we return the CPOS list. Of course, you could actually map to object, my bad. And then we want to filter that part. So if the CPOS list is different, so CPOS, and then we want to actually filter again with that metric. So CPOS list, and then return true. So that could actually be just simplify that one. So let me actually format that one, and so on. And you can just put filter on all the structure seed, and then at the end you can actually map it, or just for each, and then actually do the part here. So what is nice about stream is then you can just call parallel on it, and it will just work the magic on it. So yeah, I might not provide this one. I think I will provide it. For now I will just revert it to the previous state. And yeah, so we are done with the two first, which are mainly to get you to know about everything. And I think it's time to move on to the widget. Okay, and we are back. So now I will look at the next one, which is find quad widget seed. So a quad widget seed is actually pretty rare. So you have to, so for region, Again, you can only spawn in so much of it, so you can only spawn run please. Yeah, okay. So you can only spawn in the 24 first chunk for most of the structure, but for some different it could be a different spacing. And yeah, so now that you know that you can spawn in that, you want to have a quad widget. So quad widget can only appear here at the center of the 4 region, and for that you need to have them. So let me switch that to here. You have to have one here, one here, one here, and one here. And because this is 8 chunks apart, so if you quickly do the math, 8 times 16 is already 128. So if you want them to be correctly, so from the center you can actually get everything, because it's 128, so it's 128 square plus 128 square, and the root of that will be the distance, as Manhattan distance. Well, yeah, and you will actually need them to be quite close. So you can actually go up to 2 chunk, well, 1 chunk. So the 2 chunk here, so 4 by so 2 by 2 could be used to have a swamper. But usually you just want them in the closest chunk, because it's better to have them close, to have them all in range, because you want actually to account the size of the swamp up to be in range. And so for that, I will not actually do what we did before in the seed finder here with the position and so on. So we find here we add more air position. So we add, for example, 1 0 and 1 1, and we actually try to find a Euclidean metric such as they are all in the radius, because that will be quite slow. They are quite rare, so we will use actually math, and that's actually where the complicated part happen. So here you will find in this project actually a list of region seed, which are specific tailored to be actually quad region seed. So could be for any structure actually. Any structure, they will be a quad region seed, such as they are in this bound. So all of those are actually quad region seed. So for our next one, which is this one, so we want to find a seed for this one. We will first load the region seed, so we'll just pass some utility. There is nothing like yeah, just loading from the resource folder and then storing them here in static stuff, because we will use them. So as I said, all of those are actually region seed which are valid, but because they are at 0,0, because yeah, they are calculated at 0,0, we might want, if we, for example, that's actually not what I wanted. We might want, if you are extending, for example, the region, to move them to actually 1 0 or 1 1 and so on. And for that, you can actually just define a function which will move the structure. And for that, we will use this function. I will just pass it because it's a bit easier. And what does that do? It takes a region seed, which is a seed which is specifically seeded for that region. I will show you actually how it's seeded. And then we actually subtract the region we want to actually shift it by, times the region multiplier, and we subtract the region in the z-axis we want to subtract. And all of that we can actually mask it, because we don't care about the 16 upper bit. All of that is done on 48 lower bit. So as I said, I wanted to show you how it's actually done, and for that actually I'm going back to get in region. And why I'm doing that is because I'm going in uniform, and here I'm going in set region seed, and here you actually get how it is actually seeded. So here we get a new seed, which is just region x times the multiplier for region seed. So this is actually a number which is specific, but we abstracted it so you can use it like so. Then it adds the world seed, and then it adds the structure salt. you need to memorize that it had actually a constant. This is a constant per region, per structure and per word seed. So for a tuple region word seed structure, it's actually constant, and this only depends of region X and region Z. So because of that, we can actually pre-compute that, which is a loot. Basically, it's a lookup table. So yeah, that's all it does. Let's go back here. And so yeah, moving just means actually subtracting the region in one direction or adding them in other direction to actually move it correctly to the offset we want to go at. So that's all we need to do. So now we have the basics of it, we can start programming some stuff. So we can first iterate through all the region seeds. So as I said, all the region seeds here are known to be quad base for all the structure. So first I might want to actually have some stuff. So version, of course. Let me actually copy all of that because yeah, so I'm consistent. I will specify for the region we want to actually look at. So here we'll look at region 00, but then we will look at other region. And then I want to move the structure, the region seed, to actually get a structure seed. So to get a structure seed, I just move the structure from the region seed with my regex and regz. And I want to actually, if you recall a bit about what I said in here, let me actually get back to where I was. Get in region, then uniform here in region seed. So let me actually, so close on to right. Here you want to actually subtract the salt because it's added. So you want to subtract here the salt. So here it's a current structure, my bad. Get salt, and then you actually get the structure seed. Because remember, this is region seed. So you have region seed, which you know this quantity. So this is a region seed. You have the salt, and yeah, you want a specific one. So the word seed will be the result of that. And then you want to actually check for all of them that you have actually the biome requirement. So because those are pre-computed, you know that you will actually get at this structure seed if you spawn at region X 0 and -1, -1, -1 0 and -1 0. So because it's a 0 0 here, you know that you will get a swamp up at this position, this position, this position, and this position. So you actually know the C position. So now you want actually to check if the structure are correct. And for that you want to iterate through all the biome to actually get them. And so we will use word seed get structure get sister seed, which will give you all the upper 16-bit for that structure seed. And we will apply for that a filter, my bad, a stream. Then we will filter, and so structure seed. My bad, actually, this is a word seed already. So yeah, sister seed is basically all the up as the 64-bit seed derived from a 48-bit seed, if that makes sense. I mean, there is a lot of complicated term. I will try to make some resource of that, but there is, if you frequent some Discord, there is already some chart or stuff like that about it. Maybe I can actually find one. No, I will not find it right now, but yeah, it's basically all the one which match the 40 lower bit and then the 60 upper bit which are changed. So the same thing we did in which position here, no, here when we did that. It's the same thing, it's just an iterator. Okay, so now you want to create a biome source, of course. So biome source of then dimension. Actually, let me use get valid dimension. So yeah, it's actually changeable. Oh, actually I forgot the version again. And now we want to check the if actually at each of the position there is a correct biome for this structure. So to do that, you want to actually get for each of them the first the chunk post. But for that we will first create an utility because I'm lazy. So this getting regions the C post, it's the same thing we did before. That's why actually I show it before. Then we actually check if it can spawn at this position. So we check the structure for a region and another region. And now we want to check for the 4 regions, so we can actually define another function, which is this one. So it takes the basic region, so the one which the region seed was from, and it extrapolates the 3 other positions, which are always in that order, in that lookup table, and yeah, it gets them and checks the structure for each of them. And so for that we can actually just now return check biome, so biome source. Then we know that the regex is the one we define up top, and we want to do so for our current structure. And yeah, that's about it. So here I will change that to actually be a region structure, and that to be a structure. And yeah, that's how you do it. Now you can actually print it, and you will find that this is actually quite quick because you only need to iterate through that amount. So it's 100,000, 100k seed, and then for each seed you actually need to iterate through 2 to the power of 16. So that would be so 100,000 times 2 to 16. That's only that amount of seed, so that's, yeah, pretty much nothing. If you so import math.log that2. So that's only 32 bits. That's nothing. That can be done quickly on the computer. That's even lower than all the structure seed which exists. So yeah, that's quite fast. And yeah, we can just run that part. So let me define a main here. So quadwidget dot new and dot run, and we can run that, and we get a ton of seed. So let me take one. Let's get mind map here. Let's take the right version this time. Okay, and if we pop one out, we will see that we get indeed a quad region at 0, 0. And because we actually do it in Mania, we can actually change that. So for example, let's go at 1, 1. Again, it will be the same speed because it will do the same operation each time. Could be a bit slower if there is more sister seed which match, but yeah, it will be the same. So 1, 1, yeah. Let's go at 10, 10. 10, 10 is a bit farther away. Remember, it's 10 times 13 times 16, so 10 times 512, so it's 5k out. It's quite far out. But again, could be done, so no problem. Let's just wait for the program to complete. Sadly, we didn't have much luck with the first seed, it seems. Might be a bit of time till we actually get the next seed. Yeah, okay. Of course, each time we get like in chunk of 2 to 16 minus some which didn't match the biome, and yeah. So 500, 5,000, my bad, 5,000, yeah, as you can see, quad widget. As simple as that. There is nothing hard about this problem except the fact that actually it uses a list which is pre-computed, but because it's pre-computed you don't need to actually do it afterwards. Just need to understand that yeah, you need to check them in some order, which is this one is 0, 0, and yeah, and then you actually need to move it each time to actually match the region and so on. But that's just, yeah, linear algebra, really easy. I think Matthew Bullen might make a video about that. Anyway, that's the third one, and now we will go to the fourth one. So we are back with the example 4, which is finding a quadwidget, well, the position of quadwidget on a set seed. So this is one, find quadwidget on a set seed. So for this one we actually will use something which is a bit complex. It's a lattice, well, not really proper lattice, but basically, yeah, it's a matrix, and we will find inside the space the correct offset. So of course, because it's a set seed, we could just like iterate through all the region and find the correct one. So we have our full world with all the possible region, and we could try for all possible corner and so on. But since we also need to do that for all possible region seed which are in our local table, this adds up quite quickly. Remember, if we take a region size of 512, that means there is so 60 million divided by 512. That's approximately 120k. So 120k. Well, let me actually do the division for you. So that divided by 500 is that amount. We multiply that by 2 because we have well, we have negative and positive, and we multiply that through the next axis. So that's approximately the number of intersection. Not really, but I mean approximately. And that amount we need to multiply by the number of seeds. So it was around 100k. So that's already a large number. So to actually solve this problem, we will use something which is analysis to actually be way faster in that regard. So let me just did I actually yeah, okay. So first thing you want to do is get the region seed. That's of course some stuff I can copy from here. So I will just copy some utilities. Everything which was here except the run method I can copy because I will need them. Of course we need to load our local table, then I can copy all of that. And yeah, we are set up for that part. Now we need to actually iterate through the position, so for the region seed to find the position. So the objective is we get a word seed. We will select it afterward. I will put one for now. We get the different region seed, and we try to find for a region seed the offset, well, the position in which it will actually yield the correct result regarding the word seed. So to do that, we iterate through the region seed. This part you might actually not understand, and I'm sorry about it, but the math should be explained by Matthew. I think it's well, he made the repository, so I think he will be more capable to actually do it. So yeah. So we will use something called chunk random reversal. So if you look a bit, I actually changed some stuff in the Gradle. I excluded the current chunk random reversal because there is an issue with it, so I added a new one which is fixed. And for this one, we will try to find a position. So there is well, multiple ways to do it. Either we actually do it by going down to the method, or we can use some utility which are provided. So if you go in chunk random reversal, you have something called reverse region seed, which actually need a region seed. So this one is from our looker table, the word seed, then the salt. So the salt is from our structure. And then you need int, min, max, and so on. So those will define the full size of. Let me actually put it as as a hint. The full size of the word, so word size, and that would be 30 million. 30 million I said. 30 million. Okay, perfect. So that would be word size divided by current structure get spacing and divided by 16 again. So this we can actually put it in a variable here. So we could put it as a region size, and then we can just divide it here. So of course we need to provide the version, forgot about it. Then you need to provide the min, so region size, and actually this one we can actually calculate it. So number region, which is this number, because we actually, yeah. So okay, perfect. So if you make a quick calculus, you will see that this is actually 30 million divided by 512, so it will be around 60k. So the min is number region, it's minus number region, then minus number region, then number region, then number region. So that's our full area. So actually we should provide them before everything here. Yeah, it's not very consistent, but anyway. And yeah, if you don't, then it actually use reverse transit, which use the full length, which is maximum if you use, for example, bare treasure. But for optimization, we will use actually the correct size. Well, it's recommended, but not necessary. So if you don't care, you can just don't provide this argument and just, yeah. And then you check if the boss is different than null, and if it's different than null, then you actually print it and you get it. And so with that out of the way, we actually have it already done. And yeah, you likely didn't understand anything about what I said, and well, maybe some of what I said, but you don't understand how it works. And to be honest, explaining it is a bit out of scope of this. Bound too large to identify a unique seed. Oh yeah, because yeah, it will throw an exception, which is a bit not nice. That's why usually we do another method I will show you afterwards, and I will see it will stay in the code source, in the source code at the end. But basically, yeah, if it's empty, if there is more result, then it will actually give us index out of 1, which is, I think, not really good, because maybe you want to collect all of them. So yeah, if you want to collect all of them, then you actually want to get the result here and then, yeah, process them. So yeah, maybe if we reduce, because we know actually that well, the size is quite low. So for example, if we say that we want to go only 100 region out, then let's take actually a seed from our previous output to actually be sure that it's a quad one. So the output would be 1010. That's the target we want, because we set them at 1010 here. So it should take a few seconds. I don't remember how much time it took. I think it took 30 seconds. Yeah, it should be quite fast. Come on. Okay, so here we got one. Perfect. This is, by the way, the region seed. So if we actually print here plus the region seed, we actually will get this number. And if we go with that, we will see that we get one output. And yeah, as you can see, we get exactly this number, and with the position 1010. Okay, so that's with the utility, but the utility, as you can see, can crash, so you should try cache. It gets only the first position, in fact. But if you want to go a bit above everything, then you actually want to use that, which is basically mapping this utility to the proper one. So you need to define a region lattice, which is actually the lattice with the region coefficient and the current modulo. Then you want to use the current structure get salt. Then here we want to use the number region, like I said, number region here, number region here, and then so here we can print the solution because we actually know that well, it's a correct with the biome. We don't really care, but of course if we want to be sure, we might want to actually check that the biome are correct afterwards, because it actually will yield all the possible quad position in the world, but not all the correct quad. So if we start again, as you can see, we get a lot of quads, and when I say a lot, that's actually quite a lot. So all of those are actually quads when where you can actually go. So let me actually get everything in a nice way. So let's scale everything to our region size, and then just print as a bpos. And you will see what I mean by that, what I want to actually do with that. So let me stop that. Okay, let's go to the output. So as you can see, we are quite close to the 30 million, but we should not exceed it. And now if we load this seed, so this one, so as you can see, we got the 2020. So here, if we structure seed mode, so 2020, we should get I'm not seeing it. That's a bit concerning. This one was wrong. I'm not sure how 20 happens, because I mean, that would mean that it's not, it's 20 divided by 512. Oh my bad, actually. That's why. That's a mistake by my side. Region size should be times 16. Okay, that's more like it. So that's our 1010. So 10 times 512, you get that. And if we go at this position, so Alt G, and then this position, okay. So so let's actually disable a lot of stuff to clean everything. So that one, we disable it, we disable that one, we only left, okay, and the village were here. Okay, so here we can see that we get a quad hut, but of course that's with the structure seed mode. If we actually disable it, we see that we don't have it. So of course, when you are here, you want actually to check the biome again. So for that, you want to we can actually map here. So regex is actually solution get 0 in value, and in reg z is solution get 1 in value. And we can again check if the biome are correct. So if they are not, we just continue. And then we need to provide a biome source. So this biome source, I will just define it as before. Actually, let me get so like so, because it's a bit nicer to have it like so. And here we can provide the current structure and check biome. oh, here I should provide a regex and like seed, and then I can actually just print new new airpos, and then we regex reg z, and then the region size, and we can put it to blockforce, and we can run that, and you will see that it will get only in one position because there is only one quad on this seed, and all of that is only done in 3 seconds. So we actually iterated through all the map and through all our seed. So again, it's this number, which is quite large. Let me actually put it in bits. So that's 50 bits. We did it. So we did 50 bits of work in only 3 seconds, which is incredible, to be to say the least. And we did a few biome check also. We did actually 3 biome check if we refer to before. Well, 3 times 4 actually, but yeah, biome check are quite slow. So yeah, we are very efficient with that part. So yeah, if you want to find a quad, that's actually how to do it. But now you want to, well, you might have actually a question in your mind. What if I want to find a double? What if I want to find a triple? Then I will answer for double, this method will not work, and you should actually use the method we saw at the beginning, which was to just find the position and then calculate a distance. So if you recall, we use a metric. This is actually for double the easiest method, and it will work wonders, because a double can actually be done in a multiple way. So if you got a square, you could have a double here, you could have that's a double, that's a double, that's a double. So you have like a radius, which is, yeah, that's quite annoying to actually measure. So having a metric when you have 2, well, it's easy. To find a triple, there is actually a lot to do it, but it's quite large. So for quad, it's only 2 megabytes, so that's fine to actually embed. But for triple, I think it was 100 megabytes or something like that, maybe 80. So yeah, it's not really usable to embed. So I mean, you could make it and you could use it, but I don't think it's useful. Plus, I mean, well, triple, yeah, but they are still rare, and having quad plus triple is also super rare, and so something like that. So having one quad is fine, close to spawn, and then you actually find just double around. Like a double is quite easy to find, just need to have the correct biome and so on, and find them. So yeah, that's wrap up all the 4-part mini-series. So that was episode 1. I went a bit and show you a lot of stuff. You might not have understood anything, so if you have a question, well, put it in the comment and I will try to answer, or just in my Discord or in Monkeys or any Discord. Maybe there will be someone else which answer, but I will answer if I have the time and I am connected. Of course, as I said, because I use a current structure, you can actually swap anything with any structure. So if you want to use it for desert temple or something like that, it's possible. The issue with quad is it will only work with possible, well, it will work with any quad, but the issue is the loot is only tailored currently to the specific normal quad. So yeah, using it for other stuff, I mean, it doesn't really make sense because it's not in range when you are looking for example for ocean monument. Bows are quite well spread, so having them in a 4 formation doesn't make sense. But for example, you could find a quad outpost. Yeah, sure. There's a few more line of code to actually write, because yeah, it's a bit different. I can actually show you how to do it if you want to, but you can find quad village, you can find quad desert pyramid, igloo, jungle pyramid, ocean ruin, bastion, fortress, yeah, there is a lot of stuff you can actually find. Shipwreck actually you can find more than quad because they are quite close together. Buried treasure you can find way more than quad, that's for sure. Yeah, but I think widget was a good introduction. So next week we'll tackle how to do loot. We'll try to come up with a few application and a few example. I think it will interest a lot of you. And I think for episode 3 maybe we will look at some stuff related to terrain generation. So I will try to find something which is interesting. Of course, there is way more to all the libs and so on, so I recommend you to explore them. I'm sorry we don't have a proper doc, but we'll try to get around that and try to make one which is correct. I mean, our API is quite simple enough, but yeah, it's quite dense right now. And yeah, there is also a lot of stuff which are not supported, so yeah. Thanks for tuning in, and I hope to see you for episode 2.